Okay, I'm ready too, Eduardo. Okay, so Giselle scored 82 points on a test. Not percent, right?
Yeah.
Not percent. 82 points on a test, and that was a 12% increase over her previous test. What was her score on the previous test? That's the question, right? So Mario, here's the thing. Percentages always work this way. Always. This is always the situation, okay? So you always have your new amount. Okay? I'm just going to write the word new, okay? And the way you get your new amount, it's equal to, I'm going to write OG for the original. Like, yeah, right? OG for the original, right? It's always equal to the original, and then plus or minus some percentage of the original. That's how it works always. It's never been different. The most basic percentage problem follows that. That's how it works. Just like distance equals rate times time, always works this way as well. Always the same. Now, we're advanced here because we're fancy, especially Maria.
What?
Nothing, Maria. So, Maria, I don't like this. We can do better than this. Because this gets confusing, especially if you don't know what the original was. Like in this one, we have to find the original. We have two of them, and that makes this confusing. So what I'm going to do is I'm going to rewrite this in a different way. It's still the same. What I'm going to do, though, is I'm going to undistribute, reverse distribute. Because you see how they both have a common factor of the original amount? If I distributed this, I would get the same thing back that I started with. Doggo, you see that? Now, it says plus here, but if this was a decrease, then you would know that's a negative percentage, right? And so then it would go down. So it would be 1 minus something. So instead of her test increasing by 12, if it said decrease, then this would be minus 12. But it's increased, so it's plus 12. Okay? Paulina, do you have a question? Doggo, you got a question? No, you sure? Okay. So this is what you start with, always and forever. You always start with this with percentage problems, and then all you got to do is just plug the numbers in wherever they belong, and you know where they belong because you have to okay, I'm going to write a 4-letter word. This is... I know it's math, which is also a 4-letter word. A 4-letter word with a T and an H, and the second letter is a vowel.
Oh.
Well, the T, well, anyway, yeah. Yeah. Anyway, you have to read in order to understand the math. Math is a language. It describes relationships between numbers. Sometimes those relationships between numbers are written out in words like this. You have to read it. Otherwise, you're just doing random act of math, and those don't end up in good results usually. Once in a while, you can just see numbers and start plugging stuff into your calculator, and once in a while, you'll get it right, but most of the time you won't. And these aren't hard. If you do this, it's easy. Okay, so let's plug these in and see what happens. You ready?
Yeah.
Okay, so JC, do we know the new amount?
Yes.
We do, right? 82.
Yes.
So 82 is the new amount. Do we know the original? No. We could put X, but I think OG is kind of funny, so we're going to leave it OG. Okay,
Oh my God.
1 plus, is it going to be 1 plus or 1 minus? 1 plus. Mr. Cohen, why is it going to be plus? Increase is plus, decrease is minus. So that's going to be 1.12. Because we make this into a percentage, right? We make it, sorry, it's already a percentage. We're going to make it into a decimal. So you could do this also. You could also say 100% plus percent. Plus whatever the percentage you're given is. Yeah.
Oh, no.
Okay, so if that was confusing, I apologize. This is going to be as a decimal. Now, Giovanni, I want to make sure this makes sense to you. If we increase by 12%, That means we have everything we started with. We have 100% of what we started with and 12% more. That's it right there. If you increase by 12%, then you have 112% of what you started with. So now, after you have your beautiful, I mean, that's a beautiful, lovely equation. All you gotta do is solve it. And you've been doing that kind of math for a long time. All you gotta do is divide. And you know what's funny? There's nowhere in this problem is the number 112. You won't get this one right by just randomly plugging in numbers. So 82 divided by 112. 82 divided by 1.12. 73.2. Huh. So we're saying 73.2 is her first grade.
So you can do RAM anywhere.
You can do RAM anywhere, anytime you want, but it's not going to give you any kind of right answer or understanding. So don't do RAM. Make sure you read it. Make sure you write it. Read the question and understand it. Then you write the equation and then you solve the equation, and that's it. How can we make sure if this is right, Mario? So here's what we can do, Mario. This is the relationship right here we're going to use. Now we're going to pretend like we don't know the new score. So we're going to go, her new score, well, that would be the old score, 73.2, right? Times 1.12. And we're going to see if that equals 82. So that's my answer, times 1.12 equals, holy moly guacamole, 82.
So you can even round it up to.
Well, so I actually wrote it on paper as rounded, but I didn't actually get rid of the number in the calculator. So if I did it rounded on the calculator, it's going to give me 81.98, which is 82. Yeah.
Now I see it.
Now, Mario, you were saying you what? Right, and that's not correct. Mario, this is the correct way. Now, like, you don't have to write this, but there's other ways you can write it, but it has to use one of these two formulas right here. That's the only way to get the right answer. Because the other methods, the other formulas you would come up with, they're not how percentages work. What did you use? 82 times 0.12, right. Right. Well, here's the problem. 12% it's supposed to be 12% of her previous test, not 12% of this test. 12% of this will be different than 12% of the other. Yeah.
So that's why you could read the math.
Read it and write the equation. Do you see, Mario? That's the most common mistake. I'm glad you said that, actually. All right. In fact, I would be willing to, like, if I were going to guess how students were going to do it wrong, I would do exactly what he said. That's the most, by far, people do it wrong that way more often than they do it right. That's how often people do it like that. Yeah. Okay. Adon, doing good? Questions? No. Okay. All right. Let's do our A.